monthly meeting is going to be on supply chain security for open source projects. And it's a collaboration between GhanaJug and JFROG, sponsored by Turntable. Okay, so today's meeting is going to be the talk is going to be given by Steve. He's a developer advocate at JFROG and a Groundbreaker ambassador for Groundbreaker ambassador, and he's also a Java champion. So Steve, I guess you can take over and start. Let me stop sharing so you start here.
Okay, let's see. So, greetings from my side. Greetings from, I think for you, cold Germany. Huh? So it's, yeah, well, a bit of sun, a bit of rain, but it's okay. So we are looking forward to get some summer. But today we want to talk a little bit about supply chain security. And tomorrow there will be the practical hand-on. So today is the theoretical part. Tomorrow should be the practical part. So for everybody, it should be, yeah, a small preparation. So be aware of everything what I'm saying. No, don't worry. So tomorrow will be the practical one. Today is the theoretical one. And now the difficult task for me is starting PowerPoint. Okay, so let me see. This is mostly the critical part here. And so let me start the presentation. You can see it somewhere. Okay, so sharing screen. Wait, give me a second. Presentation with the wrong definitions. Präsentation einrichten. Always messing up with my configuration. So, okay, finally. And now you should see my screen, I hope. And I'm now getting back all my windows. By the way, if any one of you knows how to configure Zoom so that if I'm opening chat and all this stuff and then switching to the presentation mode, but all these windows are hiding, please let me know. I never got it. I have no clue why it's always hiding. Okay, so let's start with supply chain security. Supply chain security is a huge topic. Huh? By the way, if you have any questions, feel free to drop here your question into the chat. I will have an eye there so that I try to give an answer as soon as possible, to switch from giving an answer to everybody instead just of the host. And here we are. Okay, so yeah, feel free to drop anytime a question there, and I'll try to get it. So supply chain security. So what I want to cover today in the theoretical part is more or less what happened in the past, what was changing the whole thing in terms of what we have to think about if we have to work with US companies, if we have to work with governments, with big industry and all this stuff, and how to prepare to all this stuff. So this is more or less where I want to go through in the time I have. And we will start with a generic supply chain topic, narrowing it down to the supply chain for software developer and so on and so on. And in the end, for what is going on for a regular developer. So, by the way, my name is Sven Ruppert, as mentioned, and I'm developer advocate for JFROG. This is a company that's known for Artifactory mostly. Dependency manager repository, more or less. And yeah, by the way, if you want to see more of my videos, then check out my YouTube channel. I have a German one, I have an English one. Make sure that you're grabbing the right one. Yeah, so the English one for you mostly. I'm not sure if one of you is able to understand my German. But if you want to contact me, please use Twitter, LinkedIn, whatever, but no emails. Emails are just a mess. Okay, they're just, yeah. So let's see. Oh, by the way, the first 20 people will get a shirt. So I will share this link a little bit later in the chat as well. So they will find the, let me see, where's the link, the notes, the show notes. It means the slides and all this stuff. You will get there. So let me see, here's the link for you. So, and yeah, feel free to grab a shirt. Huh? So, but now, down to the targets. So what was one of the big accidents or what big things that happened in the near past that started changing a lot in terms of general awareness? It's something like the SolarWinds hack. I'm not going to all details, don't worry. So it's an old thing. I mean, the most of you will know already what was going on there. So just in short words, the software company was hundreds of thousands of customers, I think 300,000 of customers. They're producing this software to manage networks. And if you start managing networks, then you don't have to manage only one server. So you're mostly a bigger company before you're using this piece of software. So this piece of software is in a very critical position inside company networks. And they're using automatic updates to be fast with their releases and all this stuff. But this company has, for sure, a CI environment. And the hacker group, they stolen the tool set. They grabbed from FireEye as a security company. So the hacker group first hacked the security company to get their tool stack, and they use this tool stack to hack this SolarWinds, this company. And what they have done is they broke into the CI environment, manipulated the CI environment. And with every new build, they had a compromised binary. So that's it. And in the end, yeah, this compromised binary was immediately pushed to the automatic update stream, was provided to all of 300,000 customers. And I think it took 2-3 days or so, just a minimum amount of time. And they infected with this 15,000 customers. Comes around 15,000 customers. So it means they are not only affecting 15,000 servers, they killed more or less 15,000 networks. And it was so bad at some points because the software was first lying around for 1 or 2 weeks doing nothing. Then it explored a little bit local network infrastructure and started loading additional binaries. So every SolarWinds infection was more or less individual. It was a new infection. So even if you're closing the main door from SolarWinds, you never know how many open windows are left and right of this. So a bunch of institutions, governmental institutions or companies really took the whole IT network infrastructure and threw it away because they had no clue what was really going on in the system. So it was really a bad thing. So yeah, but what does it mean for us as a software developer? So for us as a software developer, it changed the way we have to think. It was before, it was in the same way, but with the SolarWinds hack, we got this very straight for the eyes to see. So why we should care about it. And this is that attacks are more and more moving from individual targets to multiplicators. So they try to break into parts of the supply chain that are good as a multiplicator. And the other thing is that we as a software developer, we don't have to protect ourselves only against not grabbing vulnerable or malicious packages, but we have to protect ourselves against don't distribute this stuff. Okay, and this is a game changer for us, so that we have to think about those ways, not only protecting and consuming, but protecting and distributing as well, because this is a way bigger thing now these days than it was 2 or 3 years ago. So supply chain security, what does it mean? Supply chain security in general is a topic that is mostly used in different contexts, but in the end, you can narrow it down to supply chain security is something that is protecting the whole production line from the idea until it's running in production, whatever it is. Could be a car, it could be, I don't know, medicals, it could be whatever, software, so everything. So supply chain security is something that is involving the whole industry, not only dedicated parts. But we saw during the last 2 or 3 years, mainly during the the pandemic period, that a few things have dramatically changed all the time. So, for example, this compromising geopolitics means that they're not only using some events or something that's happening around the world to get attention or to sneak in or to use it for phishing attacks for the first step to break in, but what we see is that earlier days you had individuals or hacker groups that try to get money out of their whatever they want to do, and you had to deal with even really good organized groups instead of just single individuals. So even this was dangerous. But now with the shift, especially during the last few months, what we see is that if you, as a small and medium business size company, working for a bigger company, a big customer of you, and this big customer is somehow not seen friendly by some other governments, that you have the challenge that you're not attacked by hacker groups, you're not attacked by individuals, you're nowadays attacked by governments, okay? And this is a huge scale. It's a huge scale, and we have to protect more and more against it, because this is, yeah, it's really used on purpose. Inside the organization of cyber criminals itself, it's more or less instead of single groups that are working more or less independently, they start now sharing collaboration in a bigger way. So they're sharing infrastructure, they're sharing information, they're sharing even people. So if someone is very specialized in something, he's then somehow, used by other groups as well. So we have a huge organization that is building between, or is built up on top of the regular, let's say, cyber criminals or this attacker groups, and they're joining forces. So this is something that is increasing the pressure dramatically. Funny motives for ransomware. So we see that this ransomware attacks was mostly in the beginning something like they want to earn money. And we saw that companies start calculating like this part of the supply chain is worth, let's say, $1 million. And if this is encrypted or attacked by ransomware, then if they want to have below $1 million, we're just paying, everything's done. If it is above $1 million, then unlikely, but we will destroy it and build it new. And so they've done it in several parts. And what we can see is that ransomware is more and more used in a political sense, not in terms of I want to earn money. Okay. And this means that they're using these techniques and all this stuff just to destroy. They're sending you this information. Yeah, you can pay so many bitcoins or whatever, but they are not even reacting to this. It's definitely not the case anymore. So a lot of these attacks are political motivated, and this is changing the world. Improved ecosystem hygiene is pushing threats up to the supply chain. Means, especially during the pandemic, a lot of infrastructure was built for home office and all this stuff. And immediately, morality points or important point of companies were distributed in a way bigger scale. And it means that these companies had to push their security enormously. And they spent a huge amount of money, human resources and all this stuff, so to improve their own security. But this means that if they are increasing their security and they're doing it with a lot of money, then it means that all the weak parts left and right of these big companies are now the main targets. And this is shifting more and more to the edges. So it means with every month, the pressure to the small and medium business size companies will increase, because the protection of the big companies will be increased as well. So, and if they're increasing, so they're increasing, it means the attacks are more and more left and right from the big company, because it's for the hacker group itself, the economy point of view, it's worse. So vulnerabilities in cloud infrastructure. So what the most people are forgetting is that if you are going into the cloud, and this makes sense in a lot of ways, it really makes sense to go to the cloud, to have resilience strategies, scalability strategies, and all this stuff. But on the other side, we're aware of hardware attacks. Hardware attacks means that, for example, companies that are providing pieces of hardware start manipulating hardware so that they have additional functionality. We have vulnerabilities in hardware that allows us, for example, to break out of our virtual environment to read the rest of the memory, for example. And it means for us as software developers, we not only have to protect our data in terms of, if I'm storing it to the database, I need an encrypted channel and I have to encrypt data that are stored there. Sometimes it's even necessary that I'm encrypting information inside my memory to make sure that it couldn't be read by left and right customers on the same hardware, okay? Because we have this hardware abstraction. Not everybody is able to have private clouds, so private or managed clouds, so really hardware that is just dedicated for them. So we have to be aware of all this stuff, and we have to broaden our view. So what is going on? This is changing a bunch. So, but from the whole supply chain security, I want to just look at a tiny part of it, and this tiny part is this supply chain security for software development. And this picture is from the open source project Salsa. I think it's Salsa.io. Wait, give me a second, then I can. Where's my mouse? My mouse is stolen. Oh, where it is. Here. So too many monitor exception. So project Salsa, SLSA. I think it's IO. I'm not sure, but Salsa is the name of the project. So the project Salsa, I will cover this in a few minutes as well, is that I took this picture from this one. So and it shows quite cool in how the typical way of software development is and where the main or most common threats are. So we are dividing threads in source, build, and dependency threads. And for you as a software developer, I'm not going into all these details here. So I have on YouTube a talk that is explicitly talking about these most common vulnerabilities as well as the project Salsa in detail. So if you want to know more about it, check out my YouTube channel. But here the short version is, for example, we have source code, and all source code change. You should be, for example, be aware that you should have a review by someone else, so that you can't sneak in with malicious code pieces. Sometimes these code pieces in open source is really provided by official mailings and all this stuff. So it really makes sense to have these reviews. With this, you're getting a bunch of this stuff killed before it's even persistent inside your pipeline. So, but then if you have this can be done by human power. So you need another person that's checking what you're doing and try to understand and then verify yes or no. From this, it's going to a source code version, something like Git server or whatever. And for sure, what can happen, the server can be hacked. So it makes sense to harden this server. It's a piece of infrastructure. You have to decide by yourself if you're using a managed one or if you're able to manage it by yourself. I think the PHP community learned this lesson very, very well after they hosted the stock by themselves. On the other side, this is a source thread, so manipulation of the source code itself in infrastructure as well as before infrastructure. So this code commit. So from this, the source code is pushed to the build infrastructure. And here we are talking about build threads, even if you're manipulating source code. For example, Webman had this attacks. So they manipulated the build infrastructure and they grabbed the original source code, overlaid with new source code, and then pushed this one to the CI environment. So they were able to sneak in between the source code and the build server. And yeah, so but we are talking already about the build thread because it's part of the build. So make sure that these two parties are communicating in a protected, secure way, maybe in zero trust environment. And then again, surprise, surprise, the build server, and the build server have different weak points. So it could be hacked by itself. So you have to protect it for sure. You have to make sure that your configuration and all this stuff is secured in a way that all changes in build infrastructure elements like the configuration as well as build configuration and all this should be done in a review as well. So I see that they have reviews on source code, but not on configurations. This makes no sense. Okay, so even configurations should be in treated like source code. It should be part of a review. So and then the build server can have compromised by itself, can be compromised by input, and can be compromised by dependencies. So if the build server is grabbing dependencies that are malicious, then you have here this dependency thread, so really grabbing from outside. So where this build server is getting all the binaries, where is the best place, how to protect everything that's coming as a binary in. But the build server itself, managed or not, must be protected. From the build server, the binaries then are pushed to the package manager and being provided in terms of releases or for consumption. Here again, make sure that this connection is protected and nobody can build a binary on his own laptop and sneak into the repository. And then the repository itself, surprise, surprise, again, make it hard. It means should it be hosted, managed, or self-hosted, or whatever, you have to make a decision by yourself. And that's more or less, and then it's going to the customer. So if you're looking at this picture, what does it mean for us as software developer? For me as software developer, it means that I have three things. Okay? It's source code. I'm manipulating by myself. It's including configuration and all this stuff. Okay. I have binaries. I'm grabbing binaries. I'm producing binaries. That's a part that I'm modifying, consuming all this. Then I have the third part that is infrastructure. So server, build server, repository server, whatever server. So, and mostly for the most developers, it's in a way that this Git server, build server, and repository server is something that is managed somehow. Not every developer is changing the build server and building its own build server and ramping up and ramping down this stuff. Mostly, if you're in a bigger organization, this is provided as a service. So it means if I'm starting as a software developer, I should focus on two things: source code, including configuration, and binaries. And the rest is more or less a strategic decision from the company or the group or whatever. Okay, so where we are. So we can now check for, let's say, 4 areas. So 4 main areas in terms of cybersecurity. And the first one is just the static application security testing. It means that I'm scanning every part I'm able to grab. So source code, configuration, binaries, everything, okay? And surprisingly, a lot of people are forgetting to scan, for example, their compilers, right? Okay. So you can have every compiler. There are nice articles out since a long time that even compilers should be checked and all these tools that what you're using. So, but thus the static application security testing means you nothing must run. You have all bits and pieces in front of you. Nothing is running, and you're just analyzing this stuff, okay, and searching for vulnerabilities, for malicious code packages, for weak configurations, all this stuff. Everything that is part of the static semantic of this, of this stuff. So it means that here you can start immediately with the first line of code. The opposite of this is DAST, dynamic application security testing. Dynamic application security testing means you're ramping up the application. It could be in test environment, it could be staging, it could be prod. And then you're looking from outside through this and try to hack this stuff. Okay, this is what you try. So you're going with the most common vulnerabilities. You try things like SQL injection or whatever to hack this system. You don't need to know the technologies that's internally used because you're just going over the API from outside. And the challenge here is, first, you need something that's already up and running. Second, the most tools that are user-friendly so that you must not be an expert in all this stuff, that are cloud-based services. It means you need somehow a big enough and stable enough connection through the internet to use these services. And the challenge here is that these dust approaches are runtime expensive. So it means the double amount of input params doesn't mean just a quarter, 4 times more runtime. It's really exponential growing in runtime with the amount of input values and the input ranges. That means there's one thing, and then what these companies are doing. The companies try to make it a little bit more intelligent in terms of fuzzing, or they try to use different patterns they found on other machines to replicate more this stuff. And mostly these providers of these services, they are not easy to customize if they are customizable. So you have to deal with, there's a set of attacks, they're running it against my machine, and then that's it. So you need a good internet connection, you need good performant hardware, otherwise these tests are just longer. And you're just looking from outside, and you're not getting all the pieces. You can't analyze all the pieces because you can just directly access the API and indirectly test the rest of the application. So the next evolution was more or less, okay, if you have Zust and if you have Dust, with all the pros and cons, so both make sense, but why not combining it? And the combination of both is called IS, Interactive Application Security Testing. It means you're ramping up the application by yourself. You're looking inside this application. You have access to all parts inside the application. And then you have attack vectors from outside. And then you are modifying attack vectors to see if you can reach certain points in this application and so on and so on. This is a very powerful tool, but you need, first of all, the infrastructure for this so that it's fast enough, and you need highly skilled people. So it's nothing what you're learning in 10 months and saying, hey, by the way, I'm a security expert, now I can do IST and you can trust me. So this is something that is, depending on the technology, a lot of experience. So you need high skilled people that are able to do it. So see it like security debugging of your application, okay? And this is more or less all of the testing approaches. The last one, even great here, is RASP, this runtime application security protection. It means I have an agent-based approach. I'm checking inside, okay, what's going on. I'm modifying the binaries. It's like a profiler. It's modifying the running app. And then I'm collecting information out of it and try to analyze if there is something not going right. Okay, and then you have two things. I can monitor and alert, or I can just shut down the application. But runtime application security protection is really the last wall of defense, and it's only able, it makes only sense on production because it's just identifying ongoing attacks. Okay, so reverse, where should I start? Okay, runtime application security protection is something, if I can afford it, then it makes sense as an additional thing, as last wall of defense. Sure. Is this the only one I should do? Definitely not. Because you are just informed you have an attack now, okay? So the next step, IS, Interactive Application Security Testing. Yeah, for sure, it's cool, but you need very high skilled people. So it means this is maybe an evolution inside your company later on. If you have Dust, you have some nice approaches, but it's mostly quite cost intensive in terms of hardware and resources and all this stuff. And you have limitations in scanning, and it's very late inside your production. So it means it is just done after a lot of stuff is already produced. And the opposite of it is Zust. You can use these tools without being a security expert. Definitely, you can scan 100% of your tools. You are focusing on 99% of your application because you have access to all these points. So if you're new to the security field, my personal recommendation is start with really static application security testing. The question is, what should you check? Your source code, your configuration, or your binaries? This we want to check in a few minutes. But I would say if you start with this, start with Zust, maybe increase with Dust. Later, if you're skilled people, make IST out of it for critical systems. And if you have the money, RASP is something for you. Okay, so a cloud native is just an excuse. It's not that I really like it or dislike it. So everything I'm saying is the same for monoliths or whatever. But it will show you some pros and cons in terms of security where you should focus on. So, for example, if you have an application and you're breaking into a microservice, there is no machine or tool that can say, okay, the use case A and B should be here, and the use case B and C should be there in this microservice. So this must be done by humans. So only we humans are able to identify what is right here. Okay, what makes sense? What use cases are isolated? What must be isolated? What use case can be compromised, and so on. Nothing to do with technology, and so tool support is crap at this point. Well, right now, maybe better in some years, but right now it's just crap. If you start thinking about how these machines are communicating through the microservice, the tools can start helping you with handshakes, encrypted lines, and all this stuff. But the decision, makes it sense to send these two pieces of information about the same wire, or should I split up or whatever? So if I can, how to make the information flow secure in terms of the knowledge, the information itself, not in terms of wrapping it in a secure channel. This is done by humans as well. So there's no tool support, but the tool support starts with infrastructure elements. So encrypting chains and all this stuff. If you're going down to the container-based infrastructure, so now you're running all these ports and you have resilient patterns, scalability patterns, you find denial of service attacks, and you can scale and run down and up and left and right and all this stuff. Tool support will be bigger, way better, because it's now a technical thing. So you don't need this domain-specific knowledge, and the tools can start helping you. But the most power of security toolings right now, these days, are inside the DevOps environment or the DevSecOps environment. So really during the production line, this is where the tools can help you as much as possible. And this is really the point where we should focus right now. All the other steps are coming over the years, maybe 5 years, maybe 10, maybe 100 years, we don't know. But right now, focus on the production line and on the runtime environment. Okay. So one thing that is very important, we are using more and more technologies that are hiding different technologies even in one stack. So if I'm talking about support for polyglot environments, I don't mean that different microservices on different technologies. Yeah, it's polyglot for sure. But what I'm talking about is that even inside one microservice, for example, if you're using tools like Barding, this open source framework for web applications, you're coding in Java, and in the end, there is a Java kernel running, but additionally an NPM stack. So the web application is built on web components. And if you have a technology that's just focusing on Java, then you're missing the whole underlying tech stack, the NPM stack, with the lifecycle, with the dependencies and all this stuff. So prepare yourself for being ready to protect the polyglot environment in every stage. So if you're looking now at this point, what I see in so many projects is the application itself. Okay, you're writing, you have your technologies, then you're laying it or pushing it on an operating system layer. And between these two layers, what it can do, you're only able to add vulnerabilities. You're not able to remove vulnerabilities. You can mask and hide or make vulnerabilities inaccessible, but you are never able to remove vulnerabilities with every additional layer. It means, per definition, with every layer you're wrapping around the technology, you are adding vulnerabilities, even if the sum is 0, but you're constantly just adding stuff. Okay, you're not able to remove it. And you have two dimensions here. You have the domain-specific part. Tools are not able to help you to understand this use case. To calculate taxes can be misused to do something stupid, but they can help you in technical things. So do you have a buffer overflow? Is SQL injection possible? Is resource management handled right? Okay, but mostly the people are focusing on their own application, but forgetting completely the DevSecOps part. Okay, the whole tool stack, CI environment, compilers, tool stacks around this, yeah, performance monitoring tools, agents that are running in the background. So this is something you should be aware of. If you're now looking at this part, so we have now the application itself, what we see is that every technology will have a corresponding dependency manager. There's nearly no technology, nearly no technology that is usable without a dependency manager in the background, because you always try to reuse stuff from outside so that you are building faster your stuff. For example, in Java applications, could be Maven, could be Gradle. On Linux, maybe it's a Debian package management system. Docker is a whole Docker universe, and Kubernetes with Helm charts, and so on and so on. Again, what a lot of people are forgetting is just the whole DevSecOps part itself. So who of you scanned the used Jenkins against vulnerabilities and fixed them? Who of you? Mostly the answer is nobody. Okay, so we have different dependency managers. Even if you have a generic one that is able to manage, for example, the binary of a compiler or the binary of some tool sets here. And then you have a bunch of metadata around these binaries. For example, let's talk about Maven. Maven itself has dependencies and transitive dependencies and so on. You have different ways to define version. Yeah, so it's you need exactly this version or range of the version and so on. Some technologies are even worse. They can describe just fetch something like latest or so. Okay, so you have direct dependencies, indirect dependencies, and with this you need the knowledge about all this stuff: runtime, statically linked, test scope, whatever. So all these different technologies or strategies from different technologies to define and manage and handle in different stages of the environment the dependencies. So with this knowledge, and this is the biggest change between our solution with Artifactory and X-Ray compared to other technologies that are just, it's a huge technology, but just scanning binaries, okay? If I'm just looking at one binary, then I have no direct information about all these dependencies. It is runtime dependencies, so what statically linked and so on and so on. So what are the dependencies around this binary? What's the context of this binary? And I need this context to get mitigation and remediation information. Okay. So if I have all this metadata of these binaries and I'm checking by the way, some dependency, and with the metadata I know immediately, with this binary, you will get the following dependencies as well. Even if you don't have it, then you have a way bigger picture of this. And Artifactory is the dependency manager, or is where all the dependencies are managed in with all the metadata. And so the next logical step was, to add a vulnerability scanner or scanner with heuristic methods and all this stuff for malicious packages or obfuscated codes and all this stuff to this Artifactory instance. And this is one of the biggest differences to other products on the market. Okay. So we have two things I just want to highlight. So as a software developer, mostly it's in a way that I have to talk to the management, and the management, they have their own words, their own meanings. So sometimes good if I'm using the same words as the management just to make sure that we are talking with the same words about the same things to describe something that's important for me as a developer. For example, time to market. What I see is a lot of these software groups or DevOps tool groups or teams, they have the allowance from a use case to produce all this stuff completely automated and pushing it to production. But if there's a vulnerability and you want to change the dependency, then you need allowance from this guy, from that guy. You have this process and that process, and it's so slow. Okay, why? So talk with your management about security means being fast, being automated, so that things can be changed as much as possible and as fast as possible. Okay, that's the thing. The other thing, make or buy. So if you're talking with the management, they're aware of, hey, there's an external consultant. Sure, if we need something, then we are hiring an external one. He's an expert here doing it, and then he's going away. Yeah, same for us. For us is make or buy. Should I write this piece of code by myself, or should I trust something that is coming from outside and I'm buying it, I'm adding a dependency? And it's the same mechanism with the same risk. So if I'm adding a dependency, I have to trust this dependency, okay? Because it's from outside, it's something. On the other side, if I'm doing everything by myself, I'm slow. I'm not an expert in everything. I have no clue about PDFs, but I have to make a PDF print function into my application. So I need external expertise. So these are two things that there should be a good communication with the management so that you have the same way of thinking about it. Okay, if you're talking about how much source code and how much binaries we have, inside an application, even if I'm writing 100,000 lines of code, I will have way more lines of code as dependency. Okay, so it means that dependencies are a way bigger part than all the stuff I wrote by myself. The same with the operating system. A few configurations, bunch of binaries. Docker starts with a from statement, and so on and so on. And the whole DevSecOps state, or the tool sec, is a binary itself. So in general, it means if I'm looking at the whole tech stack, the part I'm doing by myself is tiny compared to this huge thing that's called dependency or binaries. And this is where I should focus on. Okay, that's really the important thing. We have mostly with security two things inside the supply chain. So it's a compliance part and it's a vulnerability part. So compliance means that you're making sure that no license is killing your business. But if you find one tiny piece in the whole tech layer with the wrong license, you have to pick this out and replace it with a semantic equal implementation. That's hard, but it's just one tiny piece. Okay, it's one part that is isolated. With vulnerabilities, it's different. With vulnerabilities, I have different vulnerabilities. I can change or I can get rid of vulnerabilities in terms of same dependency, different version. But I can combine over the whole tech layer different vulnerabilities to different attack vectors. And it makes sense to get not only view in my Maven layer, I need the whole tech stack, the full impact graph, to understand what vulnerability is usable or unusable, to make the decision where should I focus on. I'm not covering the full thing here. There's a talk on YouTube about it, the lifeline of a vulnerability. I'm explaining a little bit about from it is created until it's fixed in production. The short version here is the thing we have to focus on is a part of the highest critical thing from the information. There is a vulnerability that this information is consumable by you. You have access to this information and you can use it until it's fixed in production. So this is a main thing where you can focus and influence this stuff, but it's the highest risk at this time because the information about the vulnerability is spread as much as possible. So it's really interesting to focus on, I can consume this information, and from this point, I have to automate everything in best case to get rid of this vulnerability. Okay, so what's the best tool stack we have? As a software developer, I have different vulnerability scanners and all this stuff to make sure that I'm aware of this information. There is a vulnerability, but to remove vulnerabilities, to get rid, really to remove it from our system means we need a very efficient dependency management. And this dependency management means we need a strong test coverage. A strong test coverage means not only line coverage, you need something like mutation testing or whatever. So a really strong test coverage so that you can build the same composition of dependencies in a different composition of versions. Let's a whole test suite run, and you're sure that you can say, okay, push it to production. So if you have this reach, a really strong dependency management with a really strong test coverage, then you're minimizing the amount of time from I have to change some versions to get rid of vulnerabilities, and it's running in production. And this is mostly a very, very strong weapon, and it's the best weapon we have as a software developer right now. Okay. So there's this executive order of cybersecurity from the US president. So I don't care about the US president. Why should I think about it? Well, the SolarWinds hack was so dramatic that a lot of governments were affected as well. And it means that the US president look at the US president like the CEO of a company. With this executive order, he can't change the law, but he can change the way the US government is operating. And he has done it. He just told every software that is consumed, owned, run, produced, whatever by the US government must fulfill the SBOM. What the hell is an SBOM? An SBOM is a software bills of material. It means a full list of all dependencies over all tech layers with version, artifact ID, fingerprints, and all this stuff from running system. And it means really the full system. So this is not new, that is helpful. We have the same knowledge since, I don't know, 10 years, and we called it build info. Build info is a superset of SBOM. From build info, you can generate SBOMs. So you have now this build info, and this build info is including environmental metric, environmental variables. It's what's the agent name, date, time, operating system on this agent, JDK version, compiler version, whatever. So all this stuff, plus all dependencies and so on and so on. So all this stuff will be collected over the whole tech layer. And with this, this information you can store inside Artifactory. It's called build info. We will cover this tomorrow in a practical way. So this build info must be consumable by you. I will show you how all this stuff is tomorrow. But this is more or less you're fulfilling the requirement of an SBOM, because I'm in a small and medium business company. I'm pushing something to a customer, and this customer is used by the US government. Then I have to fulfill over the time this SBOM requirement. So even if it is somewhere in the US, it will affect over long or short me as well in Europe, everywhere, in Australia, whatever, the whole world. Okay. Going back to this project, I mentioned this is a project Salsa, is an open source project, and it's a documentation project. And this documentation project is in alpha phase, but it's a cool project, even if it is alpha phase. It's from the Linux Foundation, and you will find two main documentation parts here. One is the definition of levels, where you can rank yourself where you are in security terms, and then what would be the next level to increase. And on the other side, the description of these vulnerabilities in each step with prominent examples, how to get rid of it, what you can do against it, and so on. So it's a huge amount of documentation already. It's improved nearly every week. So it's really worth to have a look at this. I can really recommend to read there a lot of stuff. And then partially implementation for open source projects is an open source project called Persia. Persia was started and founded by JFROG. It's now donated to the Linux Foundation and will be a project of the Linux Foundation in the near future. So we are just on this process. And what does it mean? It is a peer-to-peer network. It's a decentralized package management system. The long story in short words is more or less, we make sure that from the beginning of the binary will be built until it will be delivered to production, this part of the supply chain will be secured. It is not securing the part the source code is compromised, yes or no. They're at the border, but the rest. So we have source code now, build layer. So how it works in short words is you're providing a URL and a commit. Then Persia network will grab from different nodes the source code, will build it inside the build layer, will compare the binaries if they are all fitting together, if nothing is there. So just make sure that the build environment is not compromised. And then if this is true, then it will be pushed to the distribution layer to make it available in a distributed network. So we are covering different aspects here. And wait, it's too much for this hour I have right now. But I have something on my YouTube channel, a little bit more, or maybe you have some questions tomorrow. It's an open source project, and it's on alpha phase as well. It's on the way to be part of the Linux Foundation, so have a look there. It's a cool thing, and I think it's changing a lot of stuff for open source projects. So shift left. What we will cover tomorrow is shift left into the CI environment is one thing that's true, and it's necessary, and it's a secure gateway. But it's not the earliest possible moment. So if you're coding for 2 hours, pushing it to the CI environment, then you spend 2 hours already. The CI environment is complaining, pushing you back, then you lost 2 hours. Then you have to redo your stuff under time pressure, and you're bored because you have done it already. So it makes no sense. So the CI environment as a security gateway makes 100% sense. Okay, I'm not discussing this one, but the information, you should have this information earlier. And I think it's good if you have this information inside the IDE as well. So I will show you how to get this information inside your IDE. so that with the first line of definition, you already will get the whole dependency tree and we can work against vulnerabilities. The same on command line interface. You have a project, you cloned it, just make an audit of this one on command line. This makes sense. You can script it and you have the information immediately. You can expect what's going on, how much work it will be, what vulnerabilities are in, and so on and so on. And tomorrow I will show you, for example, how to deal with CVEs, with enriched information, how to deal with CVSS, what can you do with CVSS and all this stuff. And then other technologies like inside your Docker desktop environment and so on. So what I mean is we will see how early we will get this information inside our production line to make sure that with this information we can work as soon as possible so that we are not wasting time. And this is pure shift left, okay? Starting with security as early as possible. So that's a theoretical part for today. 3 minutes left. Damn, that's good. So the first 20 will get a shirt. So I put this link already to the chat. So go there, grab it. I will make from my slides and PDF, and I think it will be today or tomorrow will be shared on this page as well. Otherwise, you will get it tomorrow during my workshop. And yeah, so if there's any question, it is the right time now. Otherwise, you can ask tomorrow. Don't worry about this one. So tomorrow is a practical part. And yeah, I've created a video about workshop preparation. So if you want to attend the workshop tomorrow, it would be really, really cool if you would do all the IDE related stuff already, not the cloud stuff that we are doing tomorrow together, but all the IDE related stuff. And I think I have this video somewhere. I think it was promoted already. Let me check. I have this link. I'm just going to YouTube and checking for the right link for you so that I can give you this preparation for tomorrow. Where is Mr. Sven? And then, but no, I need the English version. English version. Where's the English version? Yeah, so English. And then this one, where's my preparation video? So by the way, I really would like to see you as my new subscriber. It's a tiny, tiny, tiny YouTube channel, but I love it. So you see a bunch of auto-related stuff there. Outdoor-related cybersecurity stuff. Okay, so how to prepare workshop preparation. I got it. Okay, I feel this workshop preparation video. If you like, prepare for tomorrow. It would make things way easy and smooth. And so now I'm searching for the chat. So if you have any questions, let me know. Otherwise, you have now homework to do to prepare your stuff. Otherwise, we are doing it tomorrow. And yeah, otherwise, if you have any questions, Twitter, LinkedIn, YouTube, whatever, no email, please. No email. That's a disaster. Okay, so that's done for today.
Okay, Sven, thank you for such a lovely talk. That was very informative. Like you said, if anybody has any question, this is a time to ask, and it's available to answer every one of our questions.
Yeah, I see one question from Dawood Ibrahim.
Yeah, Dawood has a question here.
Yeah, what are the benefits of smaller size companies, an example, startup adopting the supply chain pipeline? Something that can come later. Well, my experience with growing companies, okay, is that most of them doing the same mistake. I'm starting now, and this I'm doing later. Sure, I'm doing later. I know it's crap, but I'm doing it later. So this behavior, they're doing it over the first 1, 2, 3 years. And during this 1, 2, 3 years, they're building processes, infrastructure, selecting technologies. And to change this later is, first of all, time intensive. they will not have time. If they're successful, they will not have time to change it anymore. So in the beginning, where they have no customers, they have way more time as later if they have the first customer, okay? Because then they have way bigger pressure. And if then something is happening during the phase, they're growing, customers will lose the trust to this company, and this is even worse. Okay, so my personal opinion on this is start as early as possible with these really fully automated processes in the beginning, not overblown, but what you need, automate it as much as possible. Do it constantly. Don't think you can do it in 2 years. Okay, it's too late. It will never happen. Okay, and then you have to pay a high price. I hope I could explain it in a few words, I would.
So yeah, there's another question from Urban.
Urban, how does
Yes.
supply chain security relate to DB SQL injections? So supply chain security is something that is protecting the whole supply chain. SQL injection is the most common vulnerability. It's an attack version, and that is only one tiny thing. So I'm right now preparing. I was last week in Sweden, and I've done a recording about secure coding practices. And I will cover exactly this. So in 1 or 2 weeks, you will see it on my channel. But I'm covering all those development steps from the developer point of view. Okay, and then I will explain it a little bit more in detail. But supply chain security is a whole thing. Supply chain security for software developers, just looking in the software developer world. And SQL injection is just one vulnerability, mostly in web applications, where you can sneak in with SQL stuff in an edit field that can be misused. It's a secure coding practice in the background. I hope I could give you an answer, Arabin. Okay, thank you very much. So otherwise, if you have any questions, feel free tomorrow. We have tomorrow again time, so this is why we split it up. So you can think, you can write it down, we can have a Q&A in the beginning if you like. So it's really up to you, what makes most sense for you. And otherwise, if you have already questions, collect them for tomorrow.
Okay. I guess there are no other questions. Thanks for coming, and every other person attendees, thanks for coming, and would love to see you tomorrow.
Okay,
Yeah,
then
bye.
see you all tomorrow.
See you all tomorrow. Bye.